Today, our topic of discussion is hydrogen safety. In this section, we are going to discuss three areas. The first area is about the hydrogen leakage. The second area of hydrogen safety that we are going to see is about the intensity of the flame speed and intensity of the hydrogen fire. And finally, we will see how the fire triangle fulfill the hydrogen explosion. Now, coming to the leakage of hydrogen and its detrimental effect on atmosphere is huge, as the slide in the rightmost bottom it has already highlighted that 1 kg of liquid hydrogen is equivalent to 33 kg of CO2. In this slide, we'll try to see how the liquid hydrogen consume the hydroxyl ion, and by doing that the presence of methane prolong in the atmosphere, which is the main root cause of global warming. Apart from this hydrogen leak also dominate in growing ozone, and consequently this becomes also one of the causes of global warming. So we can say the liquid hydrogen is having a potential of 33 times of CO2 emission. Here I try to show that even teeny leakage like 10 normal meter cube per hour of hydrogen, if continue for 24 hours, it equivalent to running of one petrol car for a distance of 3200 kilometers in one day. So this is a figure which tells us even a teeny leakage also become very significant. In this slide, two things I try to highlight. One is the flammable limit of hydrogen in air, which is 4% to 75%, and second is the flame speed, which is 3.45 meter per second, which is very high compared to the gasoline or natural gas. As we can see, hydrogen flame moves 8 times faster than gasoline and 25 times faster than the natural gas, and hence we can say this hydrogen fire or explosion is very vigorous, and this is not only due to the flame speed and wide range of hydrogen, but also due to its invisibility. And here we try to show how in daytime hydrogen flame is not visible, which gets confirmed through the thermal imaging camera that hydrogen flame is there, but in naked eye it is not visible. And in night time, comparison of propane and hydrogen flame do also support that hydrogen flame is teeny and almost very small, and it is not easy to capture through the naked eyes. And in this slide it also shows that in a balloon, when a hydrogen ignited, what is the intensity of the explosion. Here I try to bring down the conditions of explosion of hydrogen. So let us see one by one. The first component for the hydrogen fire is hydrogen gas. The second is the hydrogen air mixture, and here one very favorable condition is there about a hydrogen which start from 4% to 75%, and the next condition is presence of oxygen, which is always there in a normal air. Then the condition of ignition source, and as we know, the AIT, that is auto ignition temperature for hydrogen, is 500 degrees centigrade, and a sufficient time, and if confinement is there, then this execution of explosion occur. Here I try to show how the temperature, the AIT, and our minimum ignition energy support the hydrogen combustion or hydrogen flame, hydrogen fire or hydrogen explosion. So here the most favorable combination is if AIT is there, that auto ignition temperature 500 is reached, automatically there will be fire. But if AIT is not achieved, but the minimum energy is there, that is 0.02 millijoule energy support is there, then there will be a fire. So if in a system where presence of hydrogen is there, air is there, if temperature is less and minimum support energy for ignition is not there, then even though there is a leakage or presence of air, presence of oxygen, there will be no fire. So people should see those delicate conditions in order to make the system safe and fire free. This is the example where I try to show that any installation of hydrogen projects where temperatures remains higher or minimum support energy, that is 0.02 millijoule spark, even if generated in a mobile short circuiting or some signals create such type of minimum energy generation, then hydrogen fire can easily occur. Hence, it is advised that In such installation, mobiles are not carried to the installed places. Hence, we can conclude that overall we need to prevent leakages by anyhow, because even though it is safe for a system to avoid the fire, but it kills the environment. The second is we need to ensure the ventilation. As we've seen, the intensity of the explosion due to this flame speed is very high in hydrogen. Hence, we need to provide enough ventilation. Confinedness is to be avoided. And finally, we must have to eliminate all those sources which can create a very teeny sort of energy source, like earlier we discussed about 0.02 millijoule, which can be created very easily, is to be avoided. Hence, finally, we can say that hydrogen is powerful enabler of clean energy. Everyone knows, and it has a versatile use in automobile, cement, iron, fertilizer, and so many. But it need to be handled with a lot of care, and any lapses may cost a huge risk. Thank you.